Okay, so this video is going to show us how to do the linear regression models using Desmos instead of the calculator. Okay, so the first thing you're going to have to do on the right side here, I have all the notes, and you have access to these and all the steps for finding, doing the linear regression. And on the left side, I have Desmos opened up. Okay, so first thing you have to do is go to desmos.com/calculator, and it'll take you to a screen like this. You could log in, create an account if you want. You could sign in with Google if you want. It's up to you. Okay, Desmos is usually used for graphing lines. So you would type in an equation like y equals 2x, and it would graph the line for you automatically. We don't want the line, or we want a line eventually. We don't want a line right now. We want to be able to make a scatter plot for right now. So to make a scatter plot, we're going to go plus in the top left and create a table. Okay. And then in that table, we're going to fill in the x values under x1 and the y values under y1. Okay. Now for the data, we're going to use this third page. Okay, so this is data involving the chirping rates of crickets based on temperature. So in my x column, I'm going to use temperature. In my y column, I'm going to type in the chirping rates. Okay, so you just go to the table and start with the x values. So we got 50, hit enter to get to the next line, 55, 60, 65, 70, 75, 80, 85, and then 90. Okay, and it'll automatically do them for you once you establish a pattern. But not all your data is going to have patterns. So I like to type them all in. Same thing for the y columns. Just enter your number, hit enter on your computer, and it'll keep going. 113, 140, 173, 198, and then 211. So at this point, you want to make sure that you didn't make a mistake and that your x column and your y column both match up. Okay, and in this case, they do. All right, so I got my table in there. Okay, let's go back to my steps. In the bottom left of the table box, click the magnifying glass with the plus sign in it to zoom in on the data. So right now, Desmos automatically graphs things. Right now, we have the table, but we don't see any of the values because they're not, in that window. So you could zoom out and, okay, there's the data. But how do I want to make it so that's the only thing I see? So if you click this bottom left corner, this plus sign, it's zoom fit, and it'll automatically take you to the best viewing window for your data, which is that. All right, so there's my scatter plot. I'm going to start to answer some of these questions. So that's what we want. We got the scatter plot. From the scatter plot, you can describe the data. Okay, so what type of correlation is this? Well, it's positive correlation, and it looks pretty strong as well. All right, so we'll say positive. This one's hard to write on. It's not my normal tablet. It's positive correlation. Okay. Use Desmos to find and graph the regression line. So now we have the data. Now we want to find the regression line. Okay. So to do that, we'll go back to these steps. So this first block was creating the scatter plot. Now we're going to find R and graph the line. So now we need the equation. So we're going to go back to this plus sign. And this time we're going to type in an expression. Okay. Now the expression you have to type in is a little weird. It's not an equation like we normally see. But since we have x1 values and we have y1 values, we could use those values. Okay, so we're going to call them into this expression. So we're going to type in y1. Okay, and automatically it tells you that it's a 9-element list because it's using these 9 y1 values. Okay, and it automatically does a subscript for you. So just y1. And we don't want to hit equals. Okay, we're going to use the squiggle. I don't know what it's actually called. It's a squiggle. If you hit shift and then the number to the left of 1 on your keyboard, it gives you this squiggle. Okay. So again, don't use an equal signs in here. Okay, and then you're just going to type in slope intercept form. Slope intercept form is y equals mx plus b. Instead of y, we're using y1, and instead of x, we're using x1. So y1 squiggle, and then m x1 plus b. And then Desmos pops out some information. First of all, it graphs the line, and we can see that this is the line of fit. The outputs it gives you are these. Okay, so it gives you R2. I'll write that over here. Okay. R squared value is is the square of the correlation coefficient. For right now, we want just the R value. Okay, and then it gives you M, which is obviously your slope, and B, which is the y-intercept. Okay. And again, we want the R value. Okay. All right, so let's fill this in, and we could create, finish this worksheet now. Okay. So we've used Desmos, find the regression line. The equation is just going to be y equals mx plus b. Okay. With the y and the x that popped out filled in. Okay, so the parameters down here gives you what m and what b are. So m is about 4.9. Okay, we'll round it. Okay. Mx plus the b value is negative 220. We'll round that up to negative 221. So negative 221. Okay. And then you get rid of the plus sign. So our equation for this model is y equals 4.9x minus 221. Okay, again, where x is your temperature and y is the number of chirps per minute of a cricket. Okay. All right, what's the R value, and is this a good R value? The R value, again, is out here. Okay, again, you want to use R squared you want to use R rather than R squared. R squared is always going to be positive, and we want to know if it's a negative correlation or not. So this R value is 0.9967. Okay, not only is that good, that's very good. Okay, remember that. Of R value of 1, it means it's perfect. So an R value of 9967 is very, very close to perfect. Okay. So it's yes, it's good. You could also say it's strong. It's a strong positive correlation. We already knew it was positive, but now we know it's very strong as well. All right, and then we're going to use that equation to find some information. The first two, D and E, are estimate the chirping rate. So what that means is we want to know the output when the input is our temperature. So we're going to plug in 68 for X, and then we're going to plug in 32 for X and simplify. Okay. Now again, just use the formula. 4.9 times 68 degrees minus 220, or 221. Okay. And you can just type that into a calculator. 4.9 times 68 minus 221. That gives us about 112.2 chirps per minute. Okay. So 112.2. Okay, and you should label it chirps per minute. I'm not going to label it because it's hard to write. Okay, I guess we can still do it chirps per minute. All right, is this extrapolation or interpolation? Again, that depends on your data range. Our data range in the problem was between 50 and 90. Okay, well, 68 is between 50 and 90. So that's interpolation. It's within the data range. Okay. The next problem is going to be the same thing. We're going to plug in 32 for X. And I'm not going to write it down. I'm just going to do it on the calculator. We're going to plug in 32 for X, so 4.9 times 32 minus 221. And it gives you a chirping rate of negative 64. Okay, so negative 64.2. Is this interpolation or extrapolation? This one's extrapolation because 32 is outside of our data range. Our data range, again, was between 50 and 90. Okay. And that should also be extrapolation because if a cricket can't chirp negative 64 chirps per minute. Okay, it's impossible. It's outside of the actual values that are possible. All right, and then the last two problems are what temperature would you expect if you heard 100 chirps per minute? Okay. So what this means is it's giving us chirps per minute and wants us to find the temperature. So it's giving us the Y value and it wants us to find the X value. Okay. So this time you're given the output and you have to solve for the input. Okay. Now you could estimate this looking at the table. 100 chirps per minute. It's not on the table, but it's between 91 and 113. So we should expect our temperature to be between about 65 and 70. Okay. So when you solve this equation, it's a two-step equation. Add 221 and then divide by 4.9. That's going to be 321 divided by 4.9. Okay. And you get about what we said. You get about 65.5 degrees. So that would be your temperature for about 100 chirps per minute. Okay. And the last one is, if you hear 0 chirps per minute, what temperature would you expect? And it's the same thing. You're going to plug in 0 for Y and solve for X. Okay. So add 221 to both sides and then divide by 4.9. And you would expect a temperature of about 45 degrees. Okay, so when you solve for X, you get about 45 degrees. Okay. Now again, I ran through those questions pretty quickly because we've already done problems like this. The main part of this video was to be able to graph in Desmos, okay, which we now can do. Okay. And again, your output, so put the table in, okay, put an equation in, and again, you're going to type that every single time. It's going to be the same format, y1 squiggle mx1 plus b. It gives you the m value, the slope, the b value, the y-intercept, and the r value, the correlation coefficient. Okay. And if you want to do a new one, you just exit out of these, exit out of here, and then repeat the process.